What's up? This is Dr. Taylor Krick, host of the Autoimmune Doc podcast. On this channel, I share scientific literature that I think is really cool. And today's paper is amazing. I just got it today. I'm super geeking out about it. I'm gonna make two videos about this. I'm gonna make this one. This is gonna be the long one. This is going on the YouTube channel where I review studies and literature and things, and then I'm gonna turn around and make a short one too, because the pictures in this one are great, but there's so much gold in this paper that it's going to take me a while to go through this one. This might be one of our longer videos. So let's jump right into it. So again, this came out, literally it hit my email today. So this is 2021 in the journal Oxidative Medicine and Cellular Longevity. And it's a review article, and it's got a mediocre title that says Food Origin Mycotoxin-Induced Neurotoxicity. Intend to break the rules of neuroglial cells. So first off, when I saw that title, I thought, okay, the authors do not speak English as their first language. That's really common in the science world, is you'll see like little bits of like, just the English isn't their first language. So this title doesn't make that much sense. But also food origin mycotoxin-induced neurotoxicity. What that means to me is mycotoxin-induced neurotoxicity. The brain does not care if they came from food or if they came from the mold in your basement. So this is mycotoxin-induced neurotoxicity. And it says intend to break the rules of neuroglial cells. So when I saw this title, I just started geeking out just right away. I knew it was going to be good. And it is. So mycotoxins. Mycotoxins are mold toxins. They are found in food, but they are also found in your house, in poor indoor air quality, in poor outdoor air quality with farming and things like that. There's mycotoxins, but they grow on feed and they grow on in agriculture feed. So even a lot of these people, these are ag researchers because the mycotoxins that grow on feed then are fed to animals and cause myriad of problems like neurotoxicity. So mycotoxins are key risk factors in human food and animal feed. Most food could easily enter the system, including these mycotoxins, which are some of the most common ones. We measure mycotoxins all the time on labs. For the last decade, the mycotoxin literature has been growing. For the last decade, the researchers have provided much evidence in vivo and in vitro that the brain is an important target organ on mycotoxin-mediated neurotoxic phenomenon and neurodegenerative diseases. So we know that mycotoxins are neurotoxic. We know some of these mechanisms. This is one big review talking about this, and there's a lot to this. So I try to highlight some things so I don't get distracted too. Mycotoxins. Let's just keep going. As research continues, mycotoxins have been regarded as the typical food-related exogenous toxin. So, or again, environment-related, but you can eat them. They're on cereal grains, especially things that are stored in bulk. Coffee is another famous one. That's how bulletproof coffee got started. It's the only kind of coffee that I drink because it's low mold. It's a typical toxin that can attack the brain, and some mycotoxins have been known to cross the blood-brain barrier, which could accumulate in the brain and disrupt the normal function of the central nervous system. So far, the neurotoxicity of mycotoxins involved in the predisposing factors of nerve disease is becoming better recognized by researchers. So what they're saying is neurotoxicity is becoming better recognized. In general, aflatoxin, DON, trichothekines, ochratoxin, these different fusarium fumosins have a strong affinity with the brain and could enter the systemic circulation through consumption or contact or inhalation, but get into systemic circulation, and some of their metabolites could easily cross the blood-brain barrier and reach the nerve cells via transporters. It's important to note that after this particular mycotoxin was absorbed by the gut, the blood-brain barrier was rapidly and extensively destroyed. That is really important to note. Furthermore, the fact that mycotoxin to enter the brain and develop toxins has been highlighted in recent literatures. So they talk about this. They go through all these reviews. Again, this is a review paper. Ochratoxin is a very common one that we find in kids, it's the most common mycotoxin. It affects the brain, and here's what they say. Ochratoxin is a neurotoxin that has a high affinity with the brain. The mice treated with ochratoxin showed acute depletion of dopamine and the metabolites in the striatum with excessive ochratoxin in the brain. Ochratoxin also caused male-specific autism in vivo and in vitro by combining these things. More importantly, mycotoxins have been so this is just general. Well, let me just keep going. Mycotoxins have been demonstrated to increase the occurrence of global neurological diseases. It has been reported that the concentration of trichothekines in the serum of 182 residents with a history of mycotoxin exposure was significantly increased, and neurodevelopment was hindered. Exercise balance, visual function, reaction speed, cognitive ability, and emotional management ability were all weakened. So they did a study of 182 people. They found that they were weakened in these certain neurological categories, and they also found that they had high levels of these mycotoxins. In addition, the decrease in frontal cortex activity was detected by QEEG. Mycotoxins were also suspected to be one of the triggers of autism spectrum disorder, consistent with recent epidemiological research reports on mycotoxins and autism. This is another one saying the cognitive impairment, 277 kids in Poland, a 6-year mycotoxin exposure test, indicating that the exposure time was negatively related to the IQ of participants. Basically, the longer that these kids lived in mold, the dumber they got. Similarly, the concentration of ochratoxin in urine and serum of 52 autistic patients was higher than that of control. So again, they're reviewing all these studies. Based on the characteristics of these common mycotoxins, their easy passage through the blood-brain barrier, and their potential threat to the brain, exploring the interconnections between these mechanisms is becoming more urgent for us. Then they start talking about different brain cells. So astrocytes and microglia cells, they're not only the most abundant glial cells in the brain outnumber neurons 100 to 1. You got 100 billion neurons, so you got a lot of glial cells. They're also crucial participants in both brain injury, like TBI, and neurodegenerative disorders like Alzheimer's, Parkinson's, Huntington's. Now let's stop and look at some of these pictures. These pictures are really good. Again, I'm going to do a shorter video with just these pictures. These are the mycotoxins, okay? And they come from food, and they get into animals, and the food influences us, and the animals influence us. Now again, this is an agriculture paper talking about human health, but it's an ag paper. They're not talking about indoor air quality and mold exposure, but they get in. They breach the blood-brain barrier in these tight junctions. They infect astrocytes. They infect microglial cells. That causes neuronal damage. That causes brain damage. That leads to inflammation, cerebrovascular disease, Alzheimer's, Parkinson's, Huntington's disease, persistent dystonia, ALS, MS. And that's what this graph is showing. This is crazy cool what this is showing. But let's keep going. Considering the indispensable roles of glial cells, as well as the inevitable mycotoxins, the connections are really important. Let's go to this one. The activation and proliferation of glial cells have been proven to affect the microenvironment of nerve tissue repair after injury or ischemia. So that's saying you have a stroke, you get a TBI, the activation or proliferation of glial cells matters. Excessive activation of astrocytes and microglial cells forms a glial scar and oppresses the microvessels. On the other hand, it tends to secrete harmful cytokines which affect nerve regeneration. So there's this glial scar that affects blood flow to a certain area for protective reasons, but it leads to neurodegeneration and neuroinflammation. Meanwhile, activated glial cells produce a large amount of nitric oxide, which affects DNA modification and leads to neuronal injury. Rapid and severe overactivation of glial cells caused by neurotoxic substances could lead to metabolic disturbance in the interaction between neurons and astrocytes and could result in severe brain disease. Related literatures have confirmed this process in Alzheimer's, Huntington's, demyelinating diseases, and brain trauma. So again, we just echo the same things over and over and over and over. Then we see it in a picture. Says mycotoxins cause reactive oxygen species, reactive nitrogen species, turn on these pathways, affect the mitochondria, cause a lot of calcium imbalances. Here's your environment that activates these brain cells. This is what's going on inside of them. There's mitochondrial involvement. In each of your neurons, you have around 8,000 mitochondria per neuron, so there's a heck of a lot of them in there. You get this cell cycle arrest problems, you get this DNA damage, you get this necrocytosis, and you get problems, basically. Mycotoxin-mediated microglia activation, another mechanism. This is the most classic mechanism by which neurodegeneration occurs, microglia activation. A growing number of evidences have shown that the change ratio of M1 to M2 macrophages due to excessive activation of microglia could break the balance between inflammation and repair, causing immune disorders, mediate neuroinflammatory injury, and accelerate the neurodegenerative diseases. 24-hour-long exposure to aflatoxin activated astrocytes as well as microglial cells in the form of an N1 phenotype. Subsequent microglial INOS upregulation promoted the rising of oxidative stress. To what you guys know, what that means is nothing. What that means is that microglia turned on these inflammatory mechanisms. Some of the supplements that we use in clinical practice are designed to target these pathways like INOS and NF-kappa B and these different inflammatory pathways and transcription factors and things that get turned on inside the cell. Things like curcumin, resveratrol, and vinpocetine, ginkgo, have been shown to affect these pathways in specific ways. Gene expression results indicated that increasing levels of toll-like receptors, MyD88, NF-kappa B, was evident. So basically it turned on inflammation, pro-inflammatory factors, and it turned on inflammation, basically. Oxidative stress and mycotoxin-infected glial cells. Basically, there's a lot of oxidative stress. Let's just leave it at that. Oxidative stress. Cell membrane is damaged. Not only that, brain cells are vulnerable to oxidative stress induced by mycotoxins because of numerous oxygen consumption, energy expenditure, and peroxide fatty acids in the brain tissue. Excessive ROS expression will be further increased with the injury of glial cells, thus damaging further the function of the whole CNS. It was known from previous studies that ROS and lipid peroxidation were gradually accumulated over time in the cytoplasm of human astrocytes treated with aflatoxin. So they treat a brain cell with mycotoxin, and they just get ROS, reactive oxygen species, lipid peroxidation end products, melandialdehydes, things like that, just accumulating. That's not good. As a consequence, mitochondrial permeability and DNA molecule are impaired. In addition, AST, ALT, LDH are raised in the brain. These are commonly run labs. I run them all the time. A lot of times they're considered to be like AST, ALT, or liver enzymes. They're expressed in many tissues. They're not just liver enzymes. Same with LDH. And the connectivity of the blood-brain barrier was completely destructed after 90 days. The findings of all this crap are not good. It's not good. It's been reported that INOS was upregulated after 3 hours. Oh, none of this is good, basically. The oxidative stress of normal astrocytes was initiated by 48-hour exposure to ochratoxin. Blah, 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 blah. Basically, it's not good. Now, I think mitochondrial dysfunction, oh my gosh, it keeps going. It has been proved that the regulation of ATP and calcium in glial cells was disrupted, as a consequence of mitochondrial dysfunction triggered by mycotoxins, which was also vastly involved in free radical DNA damage, cell apoptosis, and necrosis. The ability of trichothekines to inhibit mitochondrial protein translation directly has been exposed, meaning that somebody's already exposed this. We've seen this. When I got a little longer in this, it's just like I can't keep highlighting everything. Mycotoxins have been identified in recent studies as reducing the survival rate of glial cells. The sensitivity of astrocyte viability to mycotoxins has been demonstrated in previous literatures. Astrocytes really determine blood-brain barrier integrity. Studies related to cell cycle arrest have also revealed the reasons for decreased survival rate of glial cells after continuous exposure to mycotoxin. So, activated microglial cells and astrocytes both normally have the ability to release soluble factors for neuroinflammation, and their immune responses are essential for neuroinflammation. Immune effector cells, microglia, normally play an important role in immune regulation, sensing harmful stimuli, swallowing debris and abnormal proteins. They do phagocytosis. They can even phagocytose viable neurons, which is not good. Digesting apoptotic neurons and viable neurons. Shout out to my mentor Sam Yannick, who published a paper in Frontiers about that. Microglia have been recognized as internal cause of pathological neuroinflammation, like Parkinson's, Alzheimer's, ALS, MS. Latest literature, activation and pro-inflammatory response of mouse microglia exposed to aflatoxins has been evaluated. Oh my gosh. Okay, so last thing. Sublethal dose of mycotoxins can activate microglia and astrocytes and promote pro-inflammatory element release. Oh, this isn't the last thing. There's a whole other thing. Mycotoxins activate MEPK, NF-kappa B. All these pathways through the toll-like receptors promote the release of inducible nitric oxide and inflammatory cytokines like TNF-alpha, interleukin-6, interleukin-1 beta, CXCR4, interferon gamma, caspase, turn on inflammasomes, and ultimately leads to death of neuronal cells. So again, mycotoxins. At the sublethal dose, they activate microglia and astrocytes, turn on pro-inflammation, neuroinflammation, that leads to problems. At a toxic dose, what they're saying is that they kind of shut down this immune response in a way that's bad because it leads to cell death anyway. So there is one more picture. Failure of glutamate clearance. This is really important. There's a ton of anxiety, symptomatically, and glutamate's neuroexcitatory, and basically mycotoxins inhibit glutamate clearance in glial cells. Mycotoxin-mediated astrocyte injury inhibits glutamate uptake and leads to a large accumulation of glutamate. This is, again, neuroexcitatory. It excites neurons until they die, and it causes a lot of panic, oh my gosh, if something else happens, my brain's gonna explode. That's a lot of glutamate. There's the other side of the glutamate coin is GABA. GABA is the calming neurotransmitter. So this eventually induces excitotoxicity, functional impairment, and death of the nerve cells. Boy, there's a lot of problems with this stuff. So I don't even know if there's anything else that I have left to say. And I don't know how long this video's been either. It's pushing 20 minutes. That's longer than usual. So I'm just going to wrap it up. And the point is that, I'm big into mycotoxin literature. I'm big into mycotoxin mechanisms because I see a lot of people that are like, oh, all my problems started 6 years ago when I got exposed to mold. Or, boy, I got exposed to mold and then I got a donk on the head. And now I've got crazy symptoms. Or, boy, I was exposed to mold, and then now I got, long COVID, or now I got, X, Y, or Z problem, or I also have this, but I have neuro symptoms, OCD, ADHD, myriad of neurological autoimmunities, different things that are triggered, or at least mycotoxins contribute to them. They're not causative. I'm not suggesting that they caused everything, but they contribute with all those other factors that also contribute to neuroinflammation. And if you're exposed to something like mycotoxins that immediately degrades the blood-brain barrier and immediately causes all this activation of all these neuroinflammatory pathways, that's not good. That's not something you want. Whether you believe in mold toxicity or you don't believe in mold toxicity, again, it's from the food, it's from the cereal grains, it's from the coffee, it's from the things stored in bulk, it's from wines, it's from things like that. But it's also from our indoor air exposure and just air exposure in general. This study, again, is only talking about oral exposure for the most part. It's not talking even about getting through the lung and the sinus barrier. When you throw in the fact that that's even a possibility, doesn't change any of the findings of this paper, just throws in, hey, that's also a possibility, it gets even scarier. So anyway, I kind of ranted, I kind of talked fast because there was so much to cover in this, but what a heavy study and paper. Super psyched on it. Hope you guys are too.